Computer vision enables computers to interpret and process visual information from the world. This includes extracting meaningful data from images or videos. Using advanced algorithms and techniques such as machine learning and deep learning, computer vision systems can detect and classify objects, recognize images, and generate meaningful tags automatically. Microsoft Azure offers robust services within its Azure Cognitive Services portfolio that simplify the implementation of these computer vision functionalities, significantly reducing the complexity of developing custom models from scratch. Object detection refers to the capability of identifying and locating distinct objects within an image. Unlike image classification, where the goal is to categorize the image as a whole, object detection tasks involve both classification and precise localization tasks by defining bounding boxes around detected objects. Techniques commonly used include deep learning-based approaches like CNN-based models, e.g., YOLO, SSD, RCNN. These methods analyze image features, patterns, and contours, allowing objects to be accurately discerned, improving system perception capabilities in various applications like autonomous vehicles, security monitoring, and inventory management systems. Image tagging involves automatically generating descriptive labels assigned to an image based on its content. Tags represent key features, objects, and attributes found within the visual material, facilitating image searchability, organization, and future retrieval. Tags can include general categories, nature, people, buildings, specific objects, car, tree, dog, activities, running, eating, or attributes, color, size. Image tagging utilizes advanced machine learning models trained on vast datasets to achieve high accuracy and semantic richness, significantly enhancing functionality in indexing and cataloging image databases. Detecting objects and tagging images is crucial for enhanced image management, searching capabilities, and automated monitoring systems. This capability supports several practical scenarios: improved indexing and query effectiveness in image databases, enhanced content moderation by quickly flagging inappropriate content, automation of inventory and management tasks by recognizing objects and their locations, augmented reality applications by integrating computer-generated information seamlessly with a live view, security and surveillance improvements through automatic detection and scene analysis. Harnessing object detection and tagging creates efficient, scalable, and intelligent solutions applicable to numerous industries and contexts. Azure Computer Vision Service forms part of Azure Cognitive Services, empowering developers to incorporate advanced image analysis functionalities seamlessly into applications. This service provides out-of-the-box capabilities like object detection and bounding box localization, automatic image tagging based on trained datasets, text extraction, OCR, face and scene identification. Azure Service is scalable and accessible via straightforward APIs and SDKs, significantly speeding up the development process. Developers do not need extensive knowledge of machine learning algorithms or complex image processing techniques, benefiting enterprise scalability and solution maintenance. Azure Cognitive Services include robust functionalities for object detection in images. These capabilities support detecting various objects along with the coordinates of bounding boxes. Azure's Computer Vision API leverages state-of-the-art machine learning models trained on extensive datasets, delivering precise identification and delineation of multiple objects in complex images. Key functionalities include multi-object detection, bounding box coordinates, location information, robustness against variable image conditions, lighting, orientation, occlusions, easily integrated REST API calls, and SDK support for several programming languages like Python, JavaScript, and .NET frameworks. Azure's automatic image tagging identifies and provides relevant descriptive labels for objects and scenes depicted within images. When invoked, the Azure API analyzes visual content and returns tags accompanied by confidence scores, allowing developers to measure tag accuracy and relevance easily. Examples of generated tags include categories such as environment types, identifiable activities, objects, animals, or people. Tagging solutions provided by Azure are particularly powerful for automatic website content moderation, cataloging large image databases, and improving user search experiences significantly by enhancing keyword-based indexing. To utilize Azure's image detection and tagging capabilities, developers implement API calls provided by the Azure SDK. Typically, this involves provisioning Azure Cognitive Service Resource via the Azure portal, retrieving the resource's endpoint and subscription key API keys, integrating these details into API calls within application code. An example HTTP request operation might involve sending an image URL to the Azure endpoint. The API then returns JSON-formatted responses containing object bounding boxes and tags. JavaScript tags, name, tree, confidence, 0.97, objects, object, car, rectangle, x, 152, y, 395. Here is a Python code snippet demonstrating object detection using Azure SDK. Python from Azure.CognitiveServices.Vision. Computer Vision import Computer Vision client from SREST. Authentication import Cognitive Services credentials subscription underscore key equals your underscore key. Endpoint equals your underscore and DPOINT. Client equals Computer Vision client. Endpoint Cognitive Services credentials subscription underscore key. Image URL equals https://example.com/image.jpg detection underscore result equals client detect underscore objects image underscore URL for detected underscore object in detection underscore result dot objects print detected underscore object dot object underscore property detected underscore object dot rectangle. This simple yet effective implementation demonstrates Azure's uncomplicated SDK usage and the rapid integration potential of Azure Computer Vision services in practical projects. Evaluating object detection and image tagging performance involves several metrics, including precision. How many predictions were correct among the positive predictions? Recall, how many actual positives were correctly identified? Intersection over union. IOU measures the accuracy of bounding box predictions. Confidence score, provided per tag, denoting Azure's statistical confidence. Azure Cognitive Services offers certain built-in metrics and confidence indications, aiding developers instantly to measure result accuracy without needing rigorous manual evaluation processes continuously. Developers can optimize detection and tagging approaches based on these provided metrics. Several significant industries utilize object detection and image tagging: retail, inventory management, and loss prevention. Autonomous vehicles, real-time environment recognition and decision-making. Healthcare, medical diagnostic procedures, and images analysis. Security, surveillance cameras automatically analyzing footage. Social media platforms, improve content moderation and indexing. Implementation of Azure Cognitive Services enhances efficiency, accuracy, and cost-effectiveness. These examples demonstrate extensive and strategic opportunities when businesses embrace automated computer vision capabilities. Best practices when implementing object detection include: ensure images are of high quality and consistent. Evaluate and adjust confidence thresholds effectively. Continuously evaluate and retrain models when applicable. Validate scalability and performance. For image tagging specifically, regularly check errors in generated tags for content accuracy. Compare tagging confidence scores to acceptable baseline values set by developers or business analysts. Implement user feedback loops for further model training and improvement. Adherence to best practices ensures optimal, robust solutions for real-world applications that meet user expectations and business objectives effectively.